Welcome back. Hope you got a good break. How many here actually are back for reInvent that were here last year? Just a show of hands real quick. Welcome back, everybody. Everybody else, welcome to your first reInvent. Session I'm going to be talking about is called Top 10 IAM Best Practices. It's one of many IAM sessions. We had a couple earlier this morning, one that did an overview of identity and access management, and one that talked about specifically how to manage permissions in EC2 using roles in IAM. My name is Anders-Samuelsson. I work as a managed technical program management and product management within the identity team. And I'm going to be your presenter this afternoon for this. And it's going to be a little bit of jiggling here. There's a lot of demos that we're going to do, so I need to figure out how to work the two laptops. So what are we going to try and cover? We're going to do a quick overview of what identity and access management is. More of level setting, making sure that everybody sort of has a rough understanding of what it is. We're going to walk through the top 10 best practices, and we're going to do a lot of demos. I'm going to fill the full hour most likely. So if you have any questions, please keep them to the end. And if I can't get the time to answer questions, I will be up here answering questions, or we can take them outside as well. Quick question. How many people in the room today use IAM in their account? Good chunk. Good chunk. Which means the rest of you use your root credentials, and we'll get to that later, so don't worry about it. So what is IAM? IAM enables you to control who can do what in your AWS account. You can control who can do what in your AWS account. How do you do that? Well, we'll give you a number of primitives that you can play with and use to set up and work with your account. We give you users, we give you groups, we give you something that's called roles, we give you permissions, and I'll cover all these a little bit later on in the best practices. We give you the ability to control. And a lot of this is centralized. What does that mean? Well, you centrally manage your users, you centrally manage permissions, and you also centrally manage permissions for all the services. It's not that you have to go out to the individual services to work on permissions. You can actually do that centrally in one place. There are a lot of seats on the right-hand side, people. You can keep moving. It's fine-grained. What does that mean? Well, you got control it down to API level. You can control it down to resource level. And you can even control if the user is allowed to sign into the console or just use APIs when they're interacting with AWS. Security. Secure by default. What does that mean? A user that gets created with IAM cannot do anything unless you give him explicit permissions to do so. You can create multiple users, as many users as you see fit that are suitable for your environment. They can get individual credentials, and you can give them individual permissions. Very much a high-level overview of what IAM is. I'm not going to go in more detail than that. The idea here is not presenting IAM. It's talking about best practices. Let's get started. This is the hook, just to give you a little bit of a teaser of what we're going to be covering. We're going to be covering users, groups, permissions, passwords, MFA. If you don't understand what the acronym is, don't worry about it. We'll talk about it when we get to bullet number 5. We'll talk about roles, we'll talk about sharing, we'll talk about credential rotation, we'll talk about conditions, and we'll talk about root. And this is going to be an interactive session, so I expect to see hands. How many people in the room are still using root credentials when they're interacting with AWS services? Surprisingly few. That means the rest of you are not sure. We'll get to that in a little bit as well. First step, users. One of the things we want you to do as a best practice is you go in and create individual users. Benefits, unique credentials. Same thing as you have in any security or system environment that you're working in today. Take Windows or Linux. You want to have individual users and be able to have individual credentials on those users so they can sign in. If a user leaves your company or is doing a different job, you can basically transfer things in between. You can give them individual permissions. You don't have one user that everybody uses to do everything in your environment. How-to steps. Well, first of all, you need to identify who the users are that you want to give access into in your environment. It might be 1, it might be 10, it might be 20, it might be hundreds. But you need to figure that out. There's nothing that we can help you with. What we can help you with is the tools to go and create those users. And now it's a preference of how you want to do things. You either want to write your own application so you can use the APIs and go in and control IAM. Or you might be in an organization that uses a lot of scripting tools, which means you use our AWS CLI. or you actually use the console, which gives you a graphical interface you can point and click and get through things. So let's see here now. Let's see if I can get this demo stuff going. So the first thing, as I said, we need to create a user. So let's go ahead and create a new user in this case. Let's, of course, give him the name Anders. Anders is a lovely name. And I'm going to let him get access keys. And when I do that, it actually is going to say, well, you need to download the access keys. And this is the only time you're going to be able to get the whole set, the whole pair of the access keys. So only during creation. You cannot come back later and request, I want to get the access keys because somebody lost the keys. In that case, you need to create new ones. So let's make sure that we download the credentials. Good, we've done that. I've done this. I created the user, and this user can do nothing, right? No permissions, nothing in the system he can do. He exists. He has access keys. He can use those access keys to sign requests to services, but he's not going to get access to anything. And I'm going to be building on this demo moving forward. That's why it's shorter. It gets more complicated over time. So, groups. So how do you manage permissions best? Well, the best thing to do from a management perspective is using groups. You assign the permissions to a group, and you assign users to the group and, to give them the permissions. You can, of course, go and assign them to individual users if you want to, but that becomes a little bit cumbersome if you've got many users that are going to have the same permissions. You need to figure out the right policy, whatever it is. Create a group, put the policy in the group, and put users in the group. Benefit. Well, it's easier to assign the same permissions to a lot of users. It's easier to reassign permissions when a user moves between roles. You just move them from one group to another group. And you only need to change permissions in one place. And a strong recommendation, this is also, I'll call it a best practice, even if you only have one user that you want to give permissions, create a group, put permissions on that group, and put the user in the group. Because at some point, there will be some other individual in your organization that is going to need the same permissions. You just need to add that person to the group. How to do this? It's not rocket science. You do this today. You need to figure out what the business functions are that you want to go and provide permissions around. Those are essentially the groups you want to create. You want to figure out which users should be in part of those groups. And then you can use any tool that you want. Normally what we use in this case as a visual way of showing it off is using the console. So let me quickly swap here. And as I said, I've got a user here that doesn't have any permissions, Anders. So let's go ahead and create a group. So we're going to create a new group. Let's call it admins. I can't even spell. Administrator. I'll go through all these pieces of templates in a little bit later on. I'm just really quickly going to set this up so we get an admin. I'm going to add a user to the group. Look at that. I found Anders. Let's add Anders in there. Now Anders has permissions, so he can do anything in my environment. It's basically administrator. But I want him to use the console, so I want to give him the ability of signing in. So let's go back to users, select Anders, go to credentials. I'm not going to do an auto-generated. Set up a password. And this user is now going to be able to sign in. Now, for those that already use IAM, you know there's a specific sign-in URL or a specific URL that you need to use as an IAM user to sign in. It's account-specific. It can be found down on the left-hand corner of the dashboard, IAM dashboard. Just going to take a copy of this. I've happened to create an alias for mine that's called Viking. The reason being I'm from Sweden, so I'm a Viking. I stole that one so nobody else can take it. Let's paste it in up here. What you're going to see now, this is the sign-in page for an IAM user. And it has the information about the account that is signing in, and also is going to ask for username and password. And the reason you need an account in there is a username is unique only within the account. So you could have 100,000 accounts, and everybody has a user called Anders, but the combination of the account and the user will actually let you in. So let's get Anders in here. Now Anders is in, and I'm going to be using Anders for the remainder of this presentation as the admin. It's pretty straightforward. Nothing really surprising right now, and same thing with permissions. If you think about what it is that you do in an operating system like Windows or Linux or whatever it is that you run in your, on-premise, is that you have to go in and set permissions, you have to create users, and you normally do it through groups. One thing that we always recommend is you want to grant least privilege. What does least privilege mean? Well, that means you only grant the permissions that are required for a user to do his job. Benefits gives you more granular control. If you got an employee that the only thing he needs to do is be able to read from a specific S3 bucket, only give him that permission. Don't give him full-blown permissions, right? Benefit, less chance of somebody doing something wrong by mistake. If I got full permissions, I might by mistake go in and delete something that I'm not supposed to be deleting. Not because I'm doing something bad, but just because out of accident I picked the wrong file or picked the wrong instance or something like that. And it's always easier to relax than to tighten up. It's easier to relax permissions than it is to tighten up because you got more things will break when you try to tighten things up. How-to steps. Going back what we talked about before, you got the business functions. Think through and figure out what are the permissions that are specific for that job function and take those permissions and assign them to the group. Does the user need to sign into the console? Or is the user going to be using the APIs? Same thing here, it's granular. If a user's never going to sign into the console, don't give them a password. If the user's never going to use the CLI or never use an application that interacts with AWS service APIs, don't give the user access keys. If you don't want the user to do anything, don't give them access keys or password, but then the user just sits there and you can't do anything with them. Avoid assigning a star policy. Star is our terminology saying full access. You saw I created an IAM user, I had a group, and I put in a policy, and that policy was essentially a star policy. It was full permissions. Only reason I did that was I needed an admin. Other than that, don't use it. The reason being is if everybody has admin permissions, you haven't really accomplished anything. The only thing you've created are different users, but they can still go in and do anything in your environment. Use policy templates. We provided a whole set of templates for every service. It's a good starting point and helps you hone in. There's read-only policies or there's full access policies for every service that is supported by AWS. So let's do a quick demo. Oh, gotta press the button. So in this case, I'm going to go and create a group. I've got an employee called Jeff that I'm going to get access to, read-only access to my S3 buckets. I'll use a different path of creating a user and group in this case. So let's go in and create a group that we call marketing. And as I said, I want to give him S3 only access. Then you see there's a lot of policy templates here. I'm going to make sure I have read-only access. We got it there. And I can go and create a user. And I don't want Jeff to have access keys, so I'm going to deselect this, which means when I click continue, there's nothing that's prompting me to download any credentials. There are no credentials to download. And what I've done now is I've created the group and a user in one go. Very easy user interface to set this up. And as you can see, you can create multiple users at the same time if you want to. There's nothing stopping you from doing that. Let's go in and pick Jeff in this case. Make sure that he has credential, password. Same thing here. Oh, come on. Let's click there. Let's quickly sign out. Now, if we go back to the console and sign in as Jeff, the URL that I used that was specific for an IAM user, the system will recognize. We store that in a cookie, so it's not something an IAM user needs to recognize or remember every single time they're going to sign in. We will remember that for you unless you clear the cookies. But other than that, it pretty much is remembered. So Jeff signs in. I'm going to go to S3. And what you're going to see is that he now has access into S3, see all the buckets that this account has created. Anytime soon. Oh. Sorry? Route 53. Oh, my bad. No, you just want to enjoy me crashing the demo, right? Yeah. Let's sign in again. We'll fix this problem. This is the risk of doing live demos. Nothing works. Now you see how to do this again. You can go in and change the policy on it. I go down here, this is S3 read only. We sign out again. Let's go directly into the S3 consoles. I save one click. This time, fingers crossed, it should work. But ultimately what I say is, as you see, it's very easy to go in and change permissions. I missed picking the policy in this case, but I can go back and correct the error much easier. Now I can go in, Anders images, pick a file in here. I go in and try to delete this file. And it basically says operation failed, access denied. So only read access to S3. The same thing here, if I go, the other thing I wanted to show, when I try any other service, Jeff in this case is a little bit curious, is going to go and try out EC2. You're going to see he doesn't have any access to EC2 in this case. So once again, least privilege, minimize it down to really what they need with regards to their permissions. Next step, so we've set up users, we've used groups, we set up permissions with least privilege. Next step to look at is setting up a password policy or controlling what the password is in the system. It's one thing if you go in and control the permissions, but if the password is very weak and somebody can guess it, they can get in for your administrator as an example. And we provided tools to do this. So this is basically provides you with a way of better protecting your data. Password policy allows you to control, one, if people can change their password, and two, you can go in and set the complexity of the password. And you see up here, there's a bunch of stuff that we support, like length of the password, you need at least an uppercase, lowercase, et cetera. The thing to remember is when you set this, it goes across for all the different IAM users in your system, and it's not individual ones. And it doesn't apply to root, it only applies to your IAM users. And it also does not apply if you're trying to, it's not going to force an IAM user to change their password on next sign-in. It's rules that get enforced next time they try to change their password. So let's see, we have better luck this time going and changing this. And I'm going to have to sign in as Anders because Jeff doesn't have any permissions to do anything. Is that all this stuff is accessible. If you notice down here, there's this thing I can click that says password policy. So I'm going to force all the bits and pieces on this account, and I'm done. I set the policy. So next time somebody needs to change it, wants to change their password, the rules will get enforced. Where does an IAM user change their password? Easy. You go and click here, and there's a notion that says security credentials. You get a password page up. It will actually list what rules are being enforced as part of the password policy. And it's like any normal system. You go in and click, and you add, you need to use the old password first, and let's just put in simple, which does not abide with the rule, see what happens. And it basically says, sorry, you can't do this, you actually need to apply with the rules. So now I'm forcing myself to set a password that applies with the rules. Click the button. Demos are not with me today. There we go. So password change. The same thing now, if Jeff would sign in and try and go and change his password, the same rules would apply to him to go and get this enforced. So I said, everything that you've seen so far, there's nothing really new. All this stuff is things that are enforced within your on-premise environment today. Users and groups, all the bits and pieces are in place. The main difference is probably that, as I said, you centrally control all the IAM users and permissions for all the services in one place. So you actually can view it and see who has access to what at any given time. If you want to enhance this and give me even more control in the system, you'll use MFA, Multi-Factor Authentication. Our recommendation as a best practice is you assign an MFA to what we call privileged user. And it's your definition of what a privileged user is. It might be a user that is allowed to terminate instances. It might be a user that's allowed to call IAM APIs. But you have that definition. We will not make that definition for you. So what is MFA? Well, what happens is when you assign MFA to a user, they have to provide a username and a password, and then an authentication code from a device such as mobile phone, as an example. It's a unique code. We support both virtual MFA, as I said, on the phone. And the other thing we also support is hardware MFA, and these are Gemalto tokens. If you want to see what they look like, I suggest you go and talk to the Gemalto team that actually is down in the expo hall. They're here, and we'll show you the tokens that exist, and you can probably get them from them as well. And you set this up through the console like everything else. Oh, let's skip that page. So let's go set this up. And now everybody should bring out their camera because I'm going to show a QR code. So everybody get ready, take the picture. So in this case, I have a user, Anders, that I actually consider being a privileged user. I'm going to do this so you actually see a little bit better. And there's Manage MFA Device. Click on this. You select which type of device. Oh, my bad. Sorry. Thank you. There we go. And you show, basically, you're going to pick which kind of device it is, if it's a virtual device or if it's a hardware device. And the code shows up. You can't see it. I'm taking a picture in this case. Come on. There, got it. Then you have to type in 2 consecutive codes. Uh-oh. Changed the code on me. Before I could type it down. 933. There's about 30 seconds in between. Now, as an MFA tool, you could either, virtual MFA, you could either use the tool that we created, which is an Android device, Android application that can be downloaded from any Android store, or you can use Google Authenticator or whatever other application that you want. It's not tied to any specific application. Waiting for the next code here takes a little bit, takes about 30 seconds. And now we set it up. Let's quickly sign in again with Anders, and you can see exactly what actually happens here. And now it asks for a code, and I'll punch it in. Last time I did this, somebody was yelling out the code for me because they had taken a picture of the QR code. Now this actually now lets me in. So every time Anders now signs in, he's going to have to provide the code. Now the benefit of doing it on a mobile phone is that it's something I carry with me. It's naturally what I have. But if you want to be sure that it is something that you don't want to lose, it has to be a separate device, we recommend you use a hardware device. But it's a little bit your choice in that case what you want to pick. Roles for EC2. Let's get some activity in the room. Can we hold questions till the end? Thank you. So roles for EC2, quick show of hands. How many people in the room have applications that they've developed that are running on EC2 instances, and those applications are interacting with other AWS services? Hand up. Half of the room. OK, hands down. How many have built their own system of getting access keys out to the instance, either by burning them into the AMI or into the source code, or some other mechanism to get it out there? You guys should really pay attention to what I'm saying right now. So roles for EC2 is something that makes life much, much easier for you. For those that are using it, kudos, good thing. What does roles for EC2? It actually enables, it actually makes sure that we will help you get access keys out to the instance without you even touching the secret. It will take away all the muck with trying to figure out how to get it out there, key rotation, whatever other problems there might be with regarding to access keys. You get an automatic key rotation on the instance. We will rotate keys multiple times a day, which increases the security of the system, because if some keys, somebody should get access to the keys, they will expire and there's going to be new keys that are going to be used instead. You can assign least privilege. Basically defining these are things the application should be able to do when it runs, and when you get those access keys, those are the things those are things that it will have permissions to access. And if you use the SDK, the AWS SDK, all this stuff is transparent. You don't have to worry about anything. All that stuff gets solved and addressed for you. Well, how do you set it up? It sounds complicated, right? Dead simple. You create a role. You assign permissions to that role of what the application should be able to do. You launch an instance with a role, and you make sure that you're using the SDK. You can use this even if you're not using the SDK, but the SDK makes life much, much easier for you. OK, most complicated demo of the day. Let's see if we can get this going. So as I said, first step, we need to go in and create a role. Let's go and create a role that we call reinvent. In this case, it's an EC2 role, so I'll pick EC2. Let's do something simple. I'll pick a policy template, which is read-only. I'm not going to do anything specific, but I'm just picking a policy for this demo. And I'm done. I created the role. First step is good. Next step is we go over to the EC2 instance, EC2 tab, sorry. And here we're going to launch an instance. And we'll make it easy. We'll pick the first one at the top just for picking something. Configure role. And if you see here, it says IAM role. I click the drop-down. It says reinvent. That was the role I just created. I'll select it. Let's say review and launch. Yep, I'm OK with all this stuff. I'm going to do a key pair that I've pre-created. I'm not going to create a new one just to simplify the demo. And I'm done. I don't have to do anything else. Now access keys will be available to the application running on the instance. You need to figure out how to get the application out to the instance. But with regards to access keys, so getting the secret out there, we're done. Now, just to show that this actually works and show the keys that are available, I'm going to do some steps now that are not required for getting the keys out there, but it's just for demo purposes. So to start with, I have to go in here and do this. I'm going to select this, and I need the IP address, so the public DNS. I'm going to use PuTTY. And I said this is nothing to do with anything with regards to getting any kind of keys out to the system. Now, the benefit of roles is that you can use the same role to launch as many instances as you want. It's not that you have to tie one role to every single instance. So you can create an auto-scaling group, put whatever all the systems you want in there, add a role to that, and all the instances that are launched as part of that group will be launched with that role. And if you change permissions on the role, it takes effect immediately. So if you want to increase the access or limit the access or anything you want to change with permissions, you do that on the role, and it takes effect on all the instances that have been launched with that specific role. So any system that you use, like CloudFormation or any tool that goes in and launches instances, they're also able, they've been adapted so they can go in and launch instances using roles. Now let's see if this actually, oh, sorry. Let's see if we get in. Yep. So as I said, the steps that you're seeing that I'm doing now has nothing to do with getting keys out there. These are more as a way of showing that the keys are available. And I increase the font so you actually see what actually gets typed up on the system. Now, the keys are available through the metadata service, which means it's basically a local web service that you can make calls to. And this is what I'm doing here right here, doing a get to go and get it. And it said it goes and looks at a path that's called metadata, IAM, security credentials. If you look down in the left-hand corner, it says reinvent. This is the role I launched it with. If we do up here, we do reinvent. It actually shows the information. Now, somebody quickly write down the secret key. There's going to be a test after this to make sure you got all the characters correct. So it has the access key, it has the secret key, you got the token, and here's also the expiration. As I said, we rotate the keys on a regular basis on the system, many times a day. So if you write your own code, you would actually go and look at this data, you take this information, you look at the data when it's going to expire, so next time when you're closing in on the expiration, you call back to the metadata service and get new keys. Use the SDK, we'll hide all that stuff for you. So we did that. Let's go back to the presentation. So if you today are trying to figure out ways of getting access keys out there, use roles for EC2. Big thing. Sharing. How many people in the room share access into their account to third parties or others? They have stuff in their account they want to give somebody else access to. Show of hands. A whole lot of you. And you give away security credentials some way. One of the big things we want to promote, and this is really a best practice, and even if you're sharing between your own accounts, is use roles. Roles is a primitive that is very powerful and gives you a lot of functionality and enables a lot of use cases. The benefit of roles is you never need to share any credentials. The only thing you really need to share is the name of the role and the account ID where the role exists, and you can give that to anybody. You could give that to me, and I would still not get access because you haven't enabled my account. you're still under control. And sharing the name of a role and the account ID, there's no secrets, right? It's easy to break the relationship. You kill the role off, or you go in and just change take the account ID out of the trust policy that we'll talk about in a little bit. But it's easier to break this relationship than if you were sharing access keys, because sharing access keys means technically they could get their own feet and wander off and find their way out. Use cases, I talked about cross-account access. You can also use roles as a way of delegating access within the account. It's pretty much the same setup as when you would set up access across accounts, but you actually use the internal account in that case to do it. And there's also the federation aspect where you've got an identity provider like AD or something else that's on your premise, and you use that as a way of getting in and allowing users to get access. Now, there's a whole session on this tomorrow that if you're interested in trying to understand delegation into your account. It's called Delegating Access to Your Account. I don't remember, I think it's SEC301 or something like that. But you should definitely try to go to that if you're interested in this functionality. How do I set this up? Excuse me. Create a role. Specify who you trust. Who are you going to be sharing this with? And secondly, you're going to describe, if I've not shared this role with somebody else, what are they allowed to do if they actually use that role? And as I said, just share the name and the account ID. That's all you need to give out. There's no access keys or no secrets being shared in this case. Let's see if we can get this working. I should. And now what I'm going to show you now is, technically it shows the way of how you would share between accounts, but I'm going to do within the same account just for the sake of trying to save a little bit of time on demos. So as I said, what we want to do in this case, actually, I'm going to do this before I do that. Sorry. Important piece to explain how this works, because otherwise you're not going to understand what I'm doing. Got two accounts, prod and dev. I've got a user dev in the dev account that needs access to the DynamoDB database, DynamoDB table that exists in the prod account. I need to create a role, let's call it a DDB role, and I said there's two policies that need to be assigned. There's the trust policy, basically specifying who do I trust, who do I actually want to establish a relationship with in order for them to get access to something within my account. And you can see here that it goes in and specifies 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever the number is, which is the dev account. So what we're saying is there's a trust relationship set up between prod and dev. Next step is defining what can be done. And this is a DynamoDB read-only policy that allows the user to go in and read anything within DynamoDB. We're not restricting to any specific DynamoDB table, but it's for simplicity of the demo. So I'm done in the account that has the data that I want to share with somebody else. In the account that has users that want to access this data, an administrator needs to go in and assign a policy to the user, or more better, create a group, assign the policy to the group, and then the user in that case get access. It is one permission that needs to be granted. It's called assume role, and you specify the role in the other accounts. If you look at the policy, it says 11112222, and then the role name. And now I've set up a two-way relationship allowing the user Jeff to get access to the DynamoDB database. And the flow is Jeff needs to use his long-term credentials, basically say, I want to assume that role, the DDB role. And what gets handed back as in return value are temporary access credentials, similar to the ones that we saw in the metadata service on EC2. Same functionality, access key, token, and an expiration time. Then it uses those temporary credentials to interact with DynamoDB. So it's delegating access. Another way of looking at it is we're actually exchanging, it's like a credential exchange. I'm exchanging my long-term credentials for temporary credentials in another account, delegating access. So now we can do the demo. As I said, in this case, we've got, right now, we're going to be in the prod account when I set this up. So the first thing I need to do is create a role. And now I need to go in, create the role. And it's a cross-account role. We're going to pick the top one. We don't have time to go into the second one. And, sorry, yeah. And I need to open another example I have here. You need to specify the account ID from which the user is coming. The user, the account that I'm trusting in this case, where I want to grant access to somebody come in and access my resources. So that's the dev account. I'll go in and said, what did we say? We said DynamoDB read-only. Let's make sure we do the right policy. And the role is now set up. So I've set it up on the prod account. You remember the picture I had? This is all the work that was needed to be done in the prod account. If I go in this case, I'm going to set it up. Let's pretend now I'm swapping to the dev account. I'll do the simple thing. I'll create a group, and let's call this DDB access. Create the group. We're going to do a custom policy. For those that were fast, this is the policy I'm going to paste in. And this is where you have the account where the role was created. That is the ID of the prod account. Let's give it a simple name, A. Don't need to put any specific name. You need to put a name in there, but it's not really required. So now set it up in the dev account. So now really the last thing to do to make sure that Jeff can get access is I need to go in, take Jeff, add him in, and I'm done. So Jeff in this case would be able to access DynamoDB in the prod account. I'm not going to show the actual flow around it. The idea here was more to show how easy it is to go and set it up within your account. But it's two-stage approach you need to go and set up. Rotation. This is normal best practice that you have today. If you work in a company today, there's usually some policy that's set up that your password needs to rotate every 90 days or 60 days, or whatever the number is that you've picked. The difference in AWS is that you also have access keys. And access keys are secret as well as passwords are. So one of the things you need to make sure is that you also rotate your access keys, like any other secret that you're rotating. Now, the key thing here also to remember is a user cannot do anything unless you grant them permissions to do so. So if you don't give a user the permission to rotate access keys or rotate their password, it can't do that. You can change password. I showed that previously with Anders, the little drop-down, the user can go in and change their own password. But with regards to access keys, we need to be a little more careful, and I'll get to that in a little bit. But if you're using roles for EC2, and I'm really trying to hammer this in, you will get key rotation automatically. You don't have to worry about it. It actually gives that automatically while using it. Now, we can go in as that. You need to enable a user to get access. The policy that's up on the screen right now will give IAM user the ability of managing their own password. Now, what the trick here is that you should take this policy, assign it to a group, and then put the users in the group. Sorry, this one, actually, this is the presentation. Interesting. This policy will actually has to be specifically assigned to Anders. If you assign it to Jeff, Jeff is going to be able to change Anders' password. You've got to be careful about it, so you make sure you do it right. What I was actually wanted to show was there's something we released about a year ago that is called policy variables. And if you put policy variables in a policy, what it will do, it will take the policy, it will change the policy variable at runtime when it's enforcing the policy to whatever you set in. So if I could go in and change Anders to say username. So when the user tries to change and try to access, it will, at runtime, when we're validating the policy, change that username to the actual name of the user. And now you have the ability of, I can use the policy variable, have one policy for hundreds of users, but it's very specific for that user. I hope that made sense. But as with password policies, you can enforce it in a simpler way. If you set up a password policy, it gets enforced automatically. You don't have to assign a policy to users to give them the right to change passwords. It will do that automatically for you. Access keys are a little bit more tricky. Now, there's a lot of permissions here. Like I said, you could create access, et cetera. Same thing here. This policy explicitly needs to be assigned to Anders. If you use policy variables, you can create this policy and assign it to a group of users, and it will be enforced individually, and they can manage their own credentials. However, there's a 5-step process you need to go through. One, while you still have the access keys that are using currently in use, create another set of access keys, which means you have 2 pair of access keys active at any given time. And that's the maximum you can have, and the reason you have that is so you can rotate your credentials. Secondly, make sure you update your applications with the new key that you just created. And you need to know which applications are using it, or you can use, for example, CloudTrail that was discussed today as a way of potentially tracking down which applications are using your access keys. Once you've done that and you think you're done with changing all the access keys, change the state of the initial access key to inactive. Do not delete it yet. Change it to inactive. That allows you to test and validate that if you've missed anything, you can go in and fix it later. You can activate the key, and you can go in and change it, and then you deactivate it again. Once you're done with all this and it looks like it's working, then please delete the original access key. Why do I say that? It's a best practice to get rid of access keys that you are not using. Access keys could have been put in a config file or somewhere else, and if you go in and activate the keys again, they will be active, and if somebody has those keys, they have access. So whenever you're doing key rotation, make sure in the end you actually go in and delete the access keys that you originally had that you rotated from. Don't keep them laying around. And how do we do, oh, need to change here. How do we do this real quick? So if we're going to look at, we'll take users in this case. We had Anders. Look at security credentials. As you can see, he has access keys, one access key is assigned. Said the step was go in, create an access key. I need to download them. Okay, I'll download these. I've got it downloaded. I go in and test, make sure everything works fine. I can now go in and basically take the first one to say make inactive. So they're still there. They're not deleted, but I can't use them. I basically turn them off. And once I'm done, I know that everything is fine, everything works, there's nothing that's using the old access keys. I go in and just delete the keys, and I'm good. So there's more things to think about when you're rotating access keys, but please, please, please make sure you rotate access keys as well. They're as much a secret as a password is, and passwords, I promise that you guys are enforcing key password rotation on a regular basis. So. Conditions. What could conditions do? So if you think about where we started with the user, we created Anders, and he had this much permissions, and then we did least privilege, and we did this, and we honed in, more and more control. Conditions give you the ability of further controlling aspects of how people can access your resources within the account. It provides additional granularity in your system. It's enabled for all service APIs. And we'll get to in a little bit what type of conditions exist, but it's across all the service APIs. There's nothing excluded. And once again, it's one of those that minimizes somebody accidentally doing something that they shouldn't be doing. It could be that you require MFA for a very specific API as an example. And we'll get to that in a little bit. Only use them when applicable. And this is where you get the balance between security and usability. You could be very fine and hone in very far in and saying, you know what, it has to be condition A, B, C, D, and E for somebody to do something. But I might become a system that's very hard to use because I can't really figure it out and get it working. Usability goes down. But on the other hand, you might want to balance it out and say, you know what, there's certain conditions that really want to be enforced. Two types of conditions. There's AWS common conditions. And there's also security specific. The common ones are, there's 6 conditions. It's like time of day, secure transport, if you're coming, source IP, et cetera, et cetera. In the service specific, you would have to look at each service because some services have hundreds of conditions that you can go in and control, once again, to get very, very granular with regards to the access. So what's up here that you can look at are example of policies that enforce different things. The MFA one enforces, so the user needs to use an MFA, it's authenticated with MFA, if they're calling the terminate instance API, sorry. Right? The second one, SSL, basically says, well, in this case, you can't do anything with access keys unless you actually come in over SSL. And the third one, well, you could say it's source IP. We actually narrow down saying is it has to come from a specific IP address to be able to call terminate instance. These are all individual policies. You can combine all the conditions together in one and do an ANDed one. So you could have an example where you say, well, Anders, he cannot call terminate instance unless he's authenticated through MFA, he's coming in over secure transport, and the source IP is from a specific IP range. And then you can add on conditions as you please. Once again, control, least privilege. Now let's see if we can get this working. This is an interesting one. So I'm going to go and promote Jeff, and I'm going to create another group that I'm going to call marketing, thank you, marketing MFA. And essentially what I'm going to require is that when, now I need to go and get a policy again here, sorry. This policy essentially states that as long as somebody that has this policy assigned to them and they are authenticated with MFA, they will get full access to S3, which means it's read-write in this case. So we're basically giving Jeff a little bit more permissions than he had previously, but we're requiring him to authenticate with an MFA prior to being able to access. So we created the group, marketing MFA. Let's go in and add Jeff in here real quick. And given that I promoted him, I'm going to remove him out of this group. The only thing that Jeff is part of now is the marketing MFA. So let's see if this works. Once again, using a shortcut, we'll sign into S3. And at some point, somebody will guess the password. So Jeff now is signed in the normal way he does, and he gets to the S3 console, and suddenly it says, access denied, can't do anything. Why? What if you remember he signed in, nobody asked for any MFA device. So let's quickly give him the ability of using MFA. Then he'll sign in as Anders again. Oops, you need an MFA device, remember, he's a privileged user. Okay. And we go ahead and pick user. We'll pick Jeff. MFA device, yeah, we do a virtual MFA. Oh, it takes a while. There we go. And what's going to happen now is when Jeff signs in the next time, he's going to get access to EC2. But what we've done with putting this policy on Jeff, it now also states that if Jeff tries, if we had access keys and tries to use the CLI or tries to use the API, we will block it there as well unless he authenticates with an MFA device. So Anders that we gave the ability to, that we assigned an MFA device to, is not going to be required for the API calls because we only set it up for sign-in. This actually forces it to be enforced at any given time for Jeff. So I'm going to sign in here again. And now he actually is asking for MFA code that I didn't have previously. And now when we get in, S3 console is slow for some reason today. We get in, he has full access. He can go in and do anything he wants with the files that are in there. So it's a very easy way of controlling the access, using a condition is locking it down even more than you actually wanted to do previously. Now the fun part. As I said, most of you did not admit that you were using the root account, which is interesting. One of the big top 10 best practices that we really want you guys to think about and look at, if you are still using your root account or root account credentials to interact with services, try and remove that as much as possible. Why? Well, you want to lock down. One of the reasons you want to use IAM is you want to control who can do what in your environment. A root account cannot be controlled. With a root account, you can do anything you want. So if somebody has access to those, it doesn't matter what policies you put on your IAM users, the root account can bypass those. How do you go in and control this? How do you set this up? Well, there's a security credentials page. It's essentially a page that you go to control this. And the key things we want you to do, one is delete all the access keys you have on the root account. Now remember the steps I talked about when you're rotating access keys? The same thing applies here as well. You want to make sure that nothing is using those access keys. If they are, create an IAM user, create access keys, and take those access keys instead and give you to your application. Once you've deleted the access keys and taken those away, you should assign an MFA to the account. You could use a virtual MFA if you wanted to, but I remember if you do that, it belongs to the person that has the phone. It's better to use a hardware MFA and set that up to control the access. That MFA device you can lock away in the safe for the case that you actually would need the access to do things. So get rid of the access keys, lock it down using MFA. And one thing you also might want to do is ensure that you have a strong password. But if you have the MFA device, you're actually protected pretty well. And I'm not going to demo this in this case. So real quick, these are the top 10 things that we went through today, right? Create individual users, use groups to manage permissions, only assign least privileged permissions. And I see a lot of people, so let me break here and saying is, we will give out this little plastic card in the end before you leave. It's going to have all the best practices printed on the back side. We're only going to be one of the doors. I don't know exactly which one the people are going to be at, but we're going to hand them out so you don't have to take the pictures of the top 10. Passwords, MFA, make sure you use roles, both for EC2 and definitely for sharing. If you are working with a partner or an ISV that is managing your environment on your behalf and you've given out security credentials, work with that partner, talk to them about implementing roles instead. It is better for them. It is better for you. And if you have any partner that you want specifically to talk to, come to me or come to the identity team, and we will talk to that partner of engaging with them to see if they can move to roles. Rotate your credentials, use conditions, and then we came to root. If there's one thing that I want you guys to take out of the room when you're leaving as a best practice, don't use root. The one thing that I do not want you guys to do, use root. And I said it was pretty good to see. It's not as many hands up as last year, so people have started following best practices in this environment. Additional resources. There's a detailed page that talks about IAM if you want to learn more what that is. There's a forum where we hang out. Please come ask questions, anything you want. Come with feature requests, ideas that you have, or things that you see are not working. We want to know about those. There's some really good documentation, all the things that we covered. All the best practices that I just talked about are available in the documentation. I don't know, how many in here know about our security blog? Hands up. Oh, good set of hands. Go to the security blog. We put in pretty deep articles that talk about specifically how to do things that might not be covered in the documentation. And it's not just IAM, it's overall security topics regarding AWS, around compliance, as that IAM, network security, anything that's interesting from a security perspective. You can follow us on Twitter. Here's our Twitter handle. Here's a bunch of other IAM sessions that might be interesting to go to. Some of them have already happened. There's a session that's going to happen later in about 15 minutes, or whatever, 4:15. That's called Mastering Access Control Policies that I recommend today. It will go into all the details you want to know about access policies and how they're built up and how you create them. And tomorrow's a Delegating Access that goes into more details about roles. Also, if you're more interested and just want to come and have a chat with us, you can either come to the security booth, or we're going to be hosting or having a room tomorrow between 4 and 6. We can come talk security. We're going to be a bunch of us from all the different security aspects of AWS. More than welcome. Come and have a chat with us to say hi, or come with feature requests or problems that you have. SEC301, please provide feedback. Just know we're a customer-focused company, so any kind of feedback you give improving this session or improving reInvent. And as you see, they're going to draw some daily winners for everybody that's gone and completed their survey. And I think I'm pretty much out of time, so I'll say thank you very much. Appreciate the time you took. If you have questions, I will be up here for a little bit.